Hi there, welcome to Physics Lessons Online with Kaleem Akbar, endorsed author of Cambridge IGCSE Physics Explained and Edexcel International GCSE Physics Simplified. Guys, today we are going to be looking at the 2015 May-June Paper 3 Variant 1. Students of mine, my book 474, that's Paper 4, Part 2 Classified. And what we're going to be doing is looking at question number 9, which is an electrical circuits question. So here, figure 9.1, in figure 9.1, a 12-volt battery supplies a current to a circuit. The circuit contains a thermistor and a 1000 ohm resistor in parallel with a 500 ohm resistor in series. Okay, so questions like this, students find quite tricky. First of all, it's not a simple series circuit, it's not a simple parallel circuit, it's a combination of the two. And on top of that, we have a device that can change with, with the environment changing. For example, here, the thermistor, when the environment is hot, the resistance of the thermistor will go down. And when the environment is cold, the resistance of the thermistor goes up, and that has a knock-on effect elsewhere. So let's have a look at what the question has to say. It says, at a certain temperature, the thermistor has a resistance of 1000 ohms, right? And it says, calculate the combined resistance of the thermistor and the 1000 ohm resistor. So it's basically asking you to find the resistance in parallel. So what they're saying here is that this is 1000 ohms. All right, so you've got another resistor in parallel with it that's also 1000 ohms. So how do you find the total resistance? Well, it's RT equals R1, R2 over R1 plus R2. That's my preferred way of doing this. And what we'll do is we'll do 1000 times 1000 over 1000 plus 1000, and that will just give us 500 ohms. It'll be half. All right, so that's how we do the first part. Then moving on, it says calculate the current I. So what they're wanting you to do is to find the total current. So what we've got to do here is you've got the total resistance in parallel of 500. You've got another resistor in series of 500, making the total resistance in the circuit 500. And we have a 12-volt battery. So what I would suggest you do here is I equals V over R, which is 12 divided by the total resistance of 1000. Now remember why that's the case. The total resistance in parallel was 500. You've got another resistor in series of 500. So when I do 12 divided by 1000, I get 0.012 amps. Okay, so there is the total current in the circuit, because basically I've got the total voltage, you've got the total resistance, you can find the total current. I actually think that's quite a lot for 1 mark. Moving on. Then it says calculate the potential difference, in other words, the voltage across the 500 ohm resistor. Now, guys, what you've got to understand is that current of 0.012 amps is going to split when you get to parallel. So it'll be 0.012 along here. And then here it's going to split up. So some of it will go that way. In fact, half, because they're identical. Half of it will go that way. And then what will happen is it will recombine here. So you've got the total current going through the 500 ohm resistor. So to find the voltage, we simply do V equals IR, which is 0.012 times 500 and we will get 6 volts, meaning that there must be 6 volts across these two over here. Okay, so 6 volts, and that means that these two must also have 6 volts each, because basically in series it must add up to the total supply. So whether I go this way, up and round, down and along, those two must add up to 12. And whether I go along here, down and down the way, along and back up and round, it must also add up to 12. Okay. And then finally, the temperature of the thermistor is increased so that the resistance decreases. State the effect of this change in resistance on the current through the 500 ohm resistor. Explain your answer. Well, look, guys, if the temperature of the thermistor is increased, what's going to happen is the resistance in the thermistor is going to decrease. And if the resistance in the thermistor decreases, basically the overall resistance in the parallel part decreases. In other words, the resistance in the entire circuit decreases. Well, what does that mean? Well, if resistance goes down, current is going to go up. All right, so let's explain it here for 2 marks. State the effect and then explain it. The current in the 500 ohm resistor increases because the resistance of the entire circuit decreases. Well, guys, I hope you find that useful. Thank you very much.